Hey guys, Manuela here. So we're gonna learn how to solve systems of equations. That's two equations with two unknowns, and we're gonna do that using the elimination method. And the steps of the elimination method are right in this box. You gotta make sure that the two systems are lined up, meaning the x's are under the x's, the y's under the y's, the equal signs under the equal signs, and the plane number, or the plane number is just a constant under the plane number. The second step is multiply one or two of the equations by a number such that one of the coefficients has the same numeral but opposite sign. Meaning, if we're going to eliminate, let's just say the x's, and you see a positive 4 next to an x, you're going to have a negative 4 under the other. Step 3, combine the equations to solve for the remaining variable, and then plug that answer into one of the original equations and solve for the other variable. So the steps, they're a little bit hard to understand, and I get it, but once we start going through examples, you'll see what they're talking about. So in exercise 1, it says, consider the system shown below. Solve the systems two ways by eliminating x in A and eliminating y in B. So they give us the same two equations for both A and B, and they want us to solve. And so for this one, they want us to eliminate x. So step 1, we got to make sure everything's lined up, and I do. I see everything lined up. My x's are lined up, my y's are lined up, my equals are lined up, plain numbers are lined up. Step 2 says multiply one or two of the equations by a number such that the coefficients has the same numeral but opposite sign. So here we're eliminating the x's. That's the exercise. And I see that this has a 4 and this has a negative 2. So in this case, I'm thinking to myself, I only need to multiply one of these equations by a number so that I get the same number in front of the x but the opposite sign. So if I multiply everything here by a 2 and distribute, okay, I would have a negative 4x plus 2y equals 16. Okay, now since I did that, I'm going to cross this one out. I don't need to look at it anymore. And I'm going to combine both of these equations by looking up and down. And what happens is you see that a 4x and a minus 4x cancel each other out. So a 5y plus 2y is now a 7y. A 12 plus 16 is a 28. And if I divide by 7, my y equals 4. So that's my y. Now I have to solve. Now I got to find out what x is. So that was step 3, basically combining the equations to solve for the remaining variable, which I did. Now I'm going to plug this answer into one of the original equations. Okay, and it's important, original equations, and solve for the other variable. So this was one of my original equations right here. The 4x plus 5y equals 12. I'm going to substitute my 4 in for y. So I have 4x plus 5 times 4 equals 12. So 5 times 4 we know is 20. So we have 4x plus 20 equals 12. To solve for x, I first subtract the 20. So I'm left with 4x equals negative 8. Divide by 4. X equals negative 2. So now, if I wanted to get the y's by themselves, and b, we're going to get the same answers here, okay? So we're going to take this bottom equation again, and I notice that if I multiply by not just a 5, but a negative 5, I'll have the opposite sign. Since these are the same sign, I need to have a negative on the outside. And when I multiply by 5, I'm going to end up with a negative 5y here. So negative, I'm going to distribute negative 5 times negative 2x is a positive 10x. Minus 5y equals negative 40. I'm going to cross this out because I don't want to look at it. I'm going from top to bottom. When I combine a 4x and a positive 10x is a 14x. These will cancel each other out. And 12 and a negative 40 give me, when I combine them, a negative 28. Divide by 14. X equals negative 2, which I have from the other one. Now I'll take an original equation. I'll go with the top one again. You can go by the bottom one if you want, but since I kind of crossed it out, I kind of can't see it. So I want to just go by this top one here. And I'm going to substitute the negative 2 in for x. And then I'll end up solving for y. So this is a negative 8 plus 5y equals 12. Add 8 to both sides. 5y equals 20. Divide by 5. Y equals 4. So you can see it doesn't matter which one you eliminate. You can eliminate the x's or the y's and you'll be fine. Let's do exercise 2 together. Exercise 2 is a little bit more difficult because what could I multiply by the bottom one here? Let's just say I want to eliminate the x such that I get a negative 5 in front. And the whole number I can't. I mean, if I multiply by 2, I get a 4. If I multiply by 3, I get a 6. This is the case where you got to multiply both equations by 1. And the trick is multiply the bottom one by whatever the top number is. So that's going to be a 5. And the top one by whatever the bottom number is. So that'll be a 2. And then you could decide which one you want to have the opposite sign. I always like the bottom one to have the opposite sign. So I'm going to go ahead and multiply that by the negative 5. Oops, I'm a little off the screen here. Okay, so I'm going to distribute the top one, and I'm going to get 10x minus 4y equals 20. Bottom one, I'm going to get a negative 10x minus 35y, and then negative 5 times 43. Let's just go ahead and put that in the calculator real quick. Negative 5 times 43 is negative 215. So when I combine, the x's cancel. I'm left with a negative 39y equals, this will be 195, negative 195. So negative 195 divided by a negative 39 will give me a 5. Now I'm going to take this and substitute it into the original equation. Let's go with the top one here. So we have 5x minus 2y equals 10. Y is 5, so it's 5x. And then a negative 2 times 5 equals 10. So 5x equals, 5x minus 10 equals a 10. Add 10 to both sides. Those cancel. 5x equals 20. Divide by 5. X equals 4. So on those two examples, I showed you a few cases of, doesn't matter which one you eliminate, the x or the y. That was exercise 1. That's what that proved there. And here's an example where you have to multiply both equations by a number so that you can eliminate one of the variables. And again, the trick was take the bottom one, the bottom number, multiply it by what the top is. Take the top one, multiply everything there by the bottom, but you got to choose which one you want to have the opposite sign. It doesn't matter, as long as you combine correctly, you'll eliminate a variable, get to solve for a variable, substitute back in to find the other variable. These do take time. This is something that will not be very quick, but that's okay. We're going to spend a lot of time on this, and I'm more concerned about correctness. And that is eliminating or solving for systems of equations by the method of elimination.